Hey, um, we've been looking at different ways of studying the motion. So here there's relative motion. Before that, we looked at circular motion, polar coordinates, rectangular coordinates, and so on. What if we have two objects that are connected together in some way, and now we want to see how the motion of one object would result in the motion of another? So, for example, you have this block here. Say that's block A, and it's tied using this massless string or cable, such that that string or cable is now passed over this pulley system. And we have here this configuration of pulleys such that uh, this string passes over this pulley and then it comes here and then it goes to A. Okay. Now, if this here is fixed, so let's say that there is a horizontal surface over here and it is now fixed at this point here, but this pulley can move up or down. In that case, let's say then attached to the center of this pulley is another mass, and I call that mass B. Okay. If I were to pull this to the left by x, how much would this mass move? First, would it be upwards or downwards? And if this moves by x, how much would this move? Studying this kind of motion would be considered the study of constrained motion. You might be familiar with this from physics. But again, we need some kind of a coordinate system from which we can measure it. So let's say I'm measuring the position of mass A as x. Actually, I'm going to mark it as this point here as x. And then from some fixed point, let's say from this height here, I'm measuring y up to this point. So this here is y. If I do this now, and I know how much this moves to the left, that is how much does x change, then I want to know how much does y change. I want a relation between x and y. Okay. So first think about what is really the constraint over here. Imagine you're moving this to the left. What happens? You're pulling the string, moves to the left. Now this string is pulled upwards, but this end is fixed, which means then that this pulley is going to be pulled upwards so that how much ever was pulled over here will be released on this side. That was me speaking in words. But if I were to now consider that the length of the string, the total length here is constant, that would be the constraint. And if I were to now write down what is that length, it would be this x here plus there's some amount of string over here, which is going to remain constant, right? Even if the string moves to left here, the amount of string over this is going to be constant. So I'm going to write that as x plus some constant. Now gotten to this point, I have this much of the string covered. Now I have this length here, which we've defined as y. And then again, I have a constant here. I'm going to write that as another constant. So constant maybe 2. And then I have this much of measurement y. And then I have another constant for this length here. So if I were to now consider that this is a constant, these are also constants, and I move all the constants to the right side, or let's say I move the constants to the left side, I will then have L minus constant 1 minus constant 2 minus constant 3. I'll write that as some other constant k is equal to x plus 2y. Okay, where k is equal to L minus constant 1 minus constant 2 minus constant 3. So this here now gives you a relation that says how x plus 2y is going to be equal to a constant. And if I were to now differentiate this, so I now differentiate this, then I'm differentiating x plus 2y is equal to the differentiation of a constant. So this here gives me x dot plus 2y dot is equal to 0. And that tells you how much, if the velocity of this is to the left given by x dot, then how much would y dot be? Y dot would be equal to minus x dot by 2, which means that if x dot was positive in this way, y dot would be in this direction. Okay. If I were to differentiate that again, then I would have x double dot plus 2y double dot is equal to 0. These are constraint equations which relate how the physical connections between these objects, they relate to the actual position, the velocity and acceleration between the objects that are constrained. So I've gone ahead and written down and drawn the next question. It says that there's a platform that always remains horizontal, and the velocity of b with respect to a is 3.5 j hat meters per second. Then determine the velocity of a and b at this instance. So it's like someone who's standing at this platform A is looking at B, and it looks like the velocity of B with respect to A is upwards with a 3.5 meters per second magnitude. Try this yourself. I've already marked what are the measurements. So in this case, I've taken it along the pulley, the line of the pulley here. So you have YA to this, and then you have YB to the position of mass B. First, you want to write down your constraint equation. So what is the length of the string? It will be this constant plus YA plus some other constant, YA constant, YA constant, and so on. Okay, so you're just carefully writing that down. Essentially, you have 1, 2, 3, 4, 5, 6 times YA plus you have constant, 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 constant here as well, constant. There's all those constants captured. I'm going to write that as K plus you have this as YB. And if I were to now differentiate this, I would then get 0 is equal to, and essentially this also goes to 0 if you differentiate it. So you get 6YA dot plus YB dot is equal to 0. What is YA dot? That is the velocity of A, or the speed of A. And this here is the speed of B. So you have from this that VB is equal to minus 6 VA. And given to you is that the velocity of B with respect to A is equal to 3.5, or the velocity of B minus the velocity of A is equal to 3.5. So in this case, if I were to now write down velocity of B, this would be minus 6 times velocity of A. So minus 7 velocity of A is equal to 3.5. I guess here I should write J hat. Giving me the velocity of A is 3.5 by 7 with a negative sign. So minus 0.5 J hat meters per second. And the velocity of B is minus 6 times of that, gives me 3 J hat meters per second. Okay. So this here was relating the magnitudes, and I now assigned a direction. So VB direction of that would be opposite, and with magnitude 6 times that of the velocity of A. That's kind of what I did there. This here is your next question. It's given that the velocity of B is 1.2 downward, while its acceleration is 2 meters per second squared upwards. And the question asks you to determine the velocity and acceleration of A. Again, try this for yourself, but before you do, I just want to say that since the radii of these pulleys are not given to you, you see that there's a slight angle here with respect to this and a slight angle here. You can ignore the angle that comes in and just uh, assume that they are parallel. Okay. Without knowledge of the radii, you cannot take into account that angle. Try it yourself. Maybe if it helps, I can define. No, you should try to define your measurement yourself. You're looking to measure from some constant position. So first, this here is a constant position. You could measure from here as x. For y, you could measure from. You could measure from here. You could measure from here. It's up to you. I will choose to measure from here. So you can see that there's this pulley here. It's held from this position here, and this pulley is held in relation to this. It's rigidly fixed. So I'm gonna measure it from here as y, and from here as x. Again, try it for yourself. Okay, so the length of the string L is equal to, all you're doing is you're tracing it. So you have x, x, some constant, so 2x plus, this here is a constant, right? These two are not going to move with respect to each other. This is a constant, constant, constant. And now from here you have this distance, and this distance, so that's 3y. And this pulley could move up or down. So that's why this y changes. If you were to trace everything, you have some constants over here, 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 and that's all of the constants. So instead of writing plus k and then subtracting, I'm just going to write this is equal to some constant k. And now if I differentiate it, I get 0 is equal to 2x dot plus 3y dot. Essentially 2 times the speed of A plus 3 times the speed of B is equal to 0, wherein y dot is positive in this way. So I've created this unit vector ny hat in this direction, and then VA is positive in this way, so this unit vector nx hat in this direction. So if I were to write down that VB vector is equal to VB times this is the magnitude VB in ny hat. This much is equal to 1.2 ny hat meters per second. The same way VA vector, which is VA and x hat, this would be equal to, now what is VA? It is minus 3 over 2 VB. So minus 3 by 2 times 1.2, and it's in the direction of mx hat, giving me minus 1.8 nx hat meters per second, which means that since nx hat is positive in this way, this implies that this is going up the slope, which makes sense because if this was moving downward, then this pulley here is pulling the string so that it can release that much length here. And in doing that, because the length of the string is fixed, this would have to move upward. Okay, so it's releasing string here so that it can move downward. And this string that is released will imply that because the total length of the string is fixed, it will have to move. This part of the uh, constraint will cause it to move upwards. Here's the next question. There's a tractor that's trying to lift this bale of hay, perhaps, using this pulley system. So as the tractor moves to the right, this length here of the string, which is fixed, means that this pulley will have to move upwards as this tractor moves to the right. It's given to you that the tractor's forward velocity is VA. It's given to you that there's some distance x and there's some height h, which is constant with respect to the ground. You're interested in the upward velocity of the bale. Okay, so let's first create some measurement. Let's say this here is y, is the distance from the ground. And now we're interested in the total length of the cable or the string. So L is equal to, what would that be? This length here, which is root over h squared plus x squared, plus this length here, which is h minus y. And you have a constant and another h minus y. So there's 2 here. And plus a constant. I'm just going to move that to the side here. I'm going to say k is equal to this. Essentially, x dot is equal to VA. Y dot, which is equal to VB, is of interest to us. What does this mean? We have to differentiate this, and then we'll be able to find this relation between x dot and y dot. Why don't you go ahead and try this? So if we were to differentiate this, you get 0 is equal to, now this here is h squared, this is a constant, plus x squared, and x is a variable. So if I were to do using the product rule, I would get 0.5 h squared plus x squared raised to minus 0.5. And then I have to differentiate x squared. So 2x, and then this with x dot. This much minus, this goes to 0. So you have minus 2y dot is equal to 0. This here is VA. This here is VB. And if I were to now rearrange this, I would then get VB is equal to half x VA over root over h squared plus x squared. So this one was slightly different from the others because you now have to account for that hypotenuse. But essentially the same idea. You look at the constraint, which is that the total string length is fixed, and from that you obtain your velocity.